Sixth grade, lesson 13.1 is patterns in data. And you guys, this is the last chapter of the book for sixth grade. So we're almost done with your math for sixth grade. You've been doing a really great job. You've absorbed everything. I'm so proud of you. Okay, so patterns in data. We tend to use graphs like dot plots, histograms, and box plots to help us visualize data so that we can see what patterns might be happening. And so in this lesson 13.1, we will look specifically at dot plots and how those are done and what those are, and histograms, what those are. And then in the next lesson, we'll get into box plots, also known as box and whisker plots. All of which are just different ways to view data so that we can kind of visualize how all the data, the information that was gathered, laid out. So let's have a look. All right, we'll start off. We have many lakes and ponds contain freshwater fish species such as bass, pike, bluegills, and trout. Jacob and his friends went fishing at a nearby lake. The dot plot, this is a dot plot because they use dots, shows the sizes of the fish that the friends caught. What patterns do you see in the data? So they may have just written down, measured the length of the fish that once they got them out of the lake and written down the measurements. And then after they had finished fishing, maybe they decided, let's make a dot plot to put down what were the normal measurements of what were the measurements of the fish that we caught. And they used a dot to represent each of those fish. So there was one that was 5 inches, 3 fish that were 6 inches, 2 fish that were 7 inches, 2 that were 11, 3 that were 12, 1 that was 13, and 1 that was 14. Catching a total of 12 fish, it looks like. 3, 6, 7, 8, 9, 10, 11, 12, 13 fish. Okay, let's analyze that dot plot. So when we talk about dot plot, it is as simple as that. Each dot represents one of the pieces of data that was gathered, in this case, the fish that were caught. Sometimes you'll see a gap. Not always, but sometimes you'll see a gap when you look at that. And a gap is an interval that contains no data, a space that contains no data, no information. So in this case, we do have a gap. Does the dot plot contain any gaps? If so, where? Yes, we see this gap right here between 8 and 10. So between 8 and 10. Okay? So there were no fish from 8 to 10 inches long. Okay, no fish from 8 to 10 inches long is what we have discovered when we laid that out. And maybe they didn't recognize that when they just listed all these on a chart. But when they put it on a dot plot, their brain's going to go, hey, look at that, you guys. We didn't have any fish that were 8 to 10 inches long. And there were 2 clusters. Clusters are groupings. 2 clusters of fish measuring from 5 to 7 inches, and then another cluster from 11 to 14 inches. From 5 to 7 inches, and from 11 to 14 inches. So, here they said a cluster is a group of data points that lie within a small interval. The clusters from 5 to 7 and from 11 to 14. Oh, and I noticed we didn't do this. Sorry. Circle any spaces with no data. That was these. That was our gap. And then place boxes around any groups of data. These had data, and these had data. We kind of did that already. We can summarize the information shown in the dot plot. So what we can summarize is that there were only fish caught that were either 5 to 7 inches long or 11 to 14 inches long. Only 5 to 7 inches fish or 11 to 14 inch fish. That 11 does not look like an 11 at all. Let me fix that. 11 to 14 inch fish were found in there, or that they fished out of there. What conclusions can you draw about why the data from this scenario may look this way? Well, remember, they were fishing for different species: bass, pike, bluegills, and trout. There's all those possibilities in the lake. So why were some of them smaller and some of them bigger? Maybe because there's 1 or 2 types of fish that tend to be bigger, and these maybe were the bigger types of fish that maybe I don't know much about fish, so I could be totally backwards on this. But maybe bass is a larger fish in general, and the other ones are smaller fish. So the ones that they caught down here might have been the pike, bluegill, and trout ones, but the bass fish, maybe they just tend to be larger. That could have been the scenario that happened there, is why that is. And maybe these types of fish don't generally run that size. So these are smaller fish, and so those were the ones caught there. And these were bigger fish, so those were the ones caught there. That could have been why there was that gap in there, because there's different types of fish. You can word that however you want on this bottom part. So that was dot plots. It makes sense, right? The data is represented by dots on the number line is a dot plot. The other type of graph we're looking at in this lesson are called histograms. Histograms kind of lay them in intervals, 0 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. There's intervals or sections that are represented by a bar. And they look very much like a bar graph, histograms do. There's one tiny, tiny difference between a bar graph and a histogram, and that is that there's no space in between them. We just kind of stack them all together where each bar is touching each other. So if all those bars are touching each other, it's called a histogram. If they're separated from each other, sort of looking like this, then we call it a bar graph. So, but they're basically the same thing. Oops, that doesn't want to, oh, there's the eraser. Oh, we're stuck with that there now. Okay, we'll just pretend that that's not there. Okay. So let's have a look at this scenario that shows us histogram information. Erica made this histogram to show the weights of the pumpkins grown at her father's farm in October. What patterns do you see in the data? So there were pumpkins 0 to 10 pounds. There were 50 of them, numbers of them grown, 50 that were 0 to 10 pounds, little ones. Then in the interval of 11 to 20 pounds, there were a little over 100 of them, you see there. From the weights of 21 to 30 pounds, this was the majority of them. There were 200 pumpkins that were that weight. That's the majority of them. In the interval of 31 to 40 pound in weight, these are bigger pumpkins, but there were about 100 of them. And then real big pumpkins that are 41 to 50 pounds. Imagine a 50-pound pumpkin, trying to pick that up, how heavy that would be. There were about, I don't know, a little over 50, maybe 60-ish, something like that. So that's the breakdown of the pumpkins that she found. There was a lot of pumpkins there that she went through and found and weighed. All right. Identify any peaks in the data. Peaks are going to be the highest point, and so the interval with the highest number of pumpkins was 21 to 30. So this histogram has one peak. If we were to see something with more than one peak, maybe it would look like this. Like that, where we have two peaks, and that happens sometimes. In this case, with the pumpkins, it didn't. The interval representing the greatest number of pumpkins is for the weights between 21 and 30 pounds. That interval there, the most amount. Let's describe how the data changes across the intervals. We notice it climbs or increases from 0 to 21, and then it decreases from 30 down to 50. So the number of pumpkins increases from 0 to 21 pounds, and then once it hits up the 21 pounds or to 30 pounds interval, at 30 pounds the amount of pumpkins start to decrease. So we'll put decrease here. It won't fit there. I'm going to squeeze it in there. And they decrease from 30 to 50 pounds. So they climb up from 0 to 21. Their weight climbs, the amount of them increases up until you get to this point. The amount of pumpkins, the majority of the pumpkins are in that interval, and then there's fewer pumpkins that are in the higher weight class there. If I draw, so symmetry is, and they describe it over here, a geometric figure. If it has a line of symmetry, you can draw a line through it, right through the middle, so that the two parts are a mirror image, so that if you were to fold the page, it would look like it would almost perfectly match. So if I drew a line down here and I folded this page over onto this page, it almost looks like they would match. They look like a mirror image of each other. That's what they mean by being symmetrical or having symmetry. So if I draw a line through the interval for 21 to 30 pounds, the left and the right parts of the histogram are very close to being mirror images. So this histogram has line symmetry. We're going to put has there. So the data values increase to one peak in the interval for 21 to 30, I think is what they want there. It increases to 21 and decreases from there. And the data set has line symmetry about the peak. So let's talk a little bit more about symmetry because I want to make sure you're understanding that. And then that's it for this lesson. Okay, well, as we already saw, so I have a has symmetry side and a does not have symmetry side. So we already saw one that looked sort of like this. And it doesn't have to be perfect, but if it's close mirror image, if I drew a line down the peak and I folded that page over this side over to match this one, it's pretty close to a mirror image. So that has symmetry. Okay, what if it looked like this? What about that? If I drew a line down the center of that graph and I folded it over so that this side touched this side, they would match, wouldn't they? Or pretty close to it. We're talking about being pretty close. So that also has symmetry. Okay, let's look at some that do not have symmetry. If I have something that looks like this, let's say, like stair steps, and the data just keeps decreasing. If I were to go down the middle of that graph, let's say this was the middle of that graph, and fold that page over so that this side touches that side, that does not have symmetry. They're not going to match up. They're not mirror images, or at least close to being mirror images to each other. So I would say that does not have symmetry. Another example of a does not have symmetry, maybe my data looks something like this. Maybe it has two peaks. If I went down the center of that data, it's not necessarily meeting up. This folding over to here is not going to match up. It's not going to be mirror imaged. So that would be something that does not have symmetry. So hopefully those examples for you help to understand what they mean by has symmetry or does not have symmetry. And dot plots can also have symmetry too. Maybe you had a lot of your dots like this. There's a dot plot with symmetry. There's a dot plot with symmetry here. Oh, well, that doesn't really fall. I'll have to give these more. There we go. That does not have symmetry. You get the idea. So, so dot plots also, you could say they have symmetry or they do not have symmetry. If you put a line of symmetry down the middle, would they meet up and match each other when you folded the page that way? Are they mirror images of each other? That's it for this lesson. I think you're going to do really well. Good luck.